Hi, madam. Our group will talk about the application of apparatus, techniques, and reagent in water quality analysis. Our group member consists of myself, which is Nur Intan, Marisa Lipa, Nur Natasha, and Felicia.
Hello everyone, I am Nur Natasha and today we are diving into the applications of apparatus, techniques, and reagents in water quality analysis. As we all know, water is absolutely essential for human health, industry, and agriculture. However, ensuring the safety isn't something we can do by guessing. It requires accurate chemical analysis to determine the chemical composition, hardness, acidity, contaminants. An accurate analysis depends on proper apparatus, techniques, and reagents.
Why water quality matters? Water quality matters because it is very essential for humans to protect their health, to preserve our ecosystem and biodiversity, to support industrial and environmental sustainability. A safe and quality water means a safe water and environment. If the water is safe, it is good for our communities or humans to drink. Therefore, it also safe for our ecosystem and biodiversity from being polluted by any chemical or microorganism. Next, water quality matters because of industrial and public health. If the water is good to drink, that means no any disease outbreak that will bring human in danger. Lastly, if the water is not in good quality, the water will be harmful toward humans or any ecosystem because it is contaminated by probably heavy metal, pathogens, or chemical. Now, I will talk about the first apparatus that used in water quality analysis, which is analytical balance. An analytical balance is an instrument that used to measure the mass of chemical accurately. For example, we can use analytical balance to weigh 100 grams of standard reagent to do chemical analysis. But in time, what is the importance of analytical balance in water analysis? Well, analytical balance help us humans or intern prepare a standard solution with precise concentration. Next, analytical balance also helps to reduce the measurement errors for accurate results. Analytical balance is also a critical aspect for titration. Therefore, it is very important to have analytical balance in water analysis.
Hello, I am Melissa, and on this slide, I will talk about the second apparatus that is used in water quality analysis, which is volumetric glassware. Volumetric glassware is essential in water quality analysis for preparing standard solutions and measuring precise volumes. Accurate volume measurements directly improve the reliability and reproducibility of analytical results. There are three equipment for volumetric glassware and its function, which are volumetric flask to prepare standard solutions, second is pipette to transfer precise volumes, and lastly is burette to perform accurate titration. This apparatus is important so that we can get the accurate volume measurements to improve analytical reliability and minimize errors in water quality determinations such as hardness and pH analysis. On this slide, I will talk about the techniques that is used in water quality analysis, which is titration. Titration is a reaction occurs between a standard solution, which is titrant, and the water sample to determine chemical concentration accurately. Titration can be used in water hardness determination, alkalinity measurement, and chloride analysis. Titration is recommended because it is easy to perform, accurate and reliable, and cost-effective method. This technique is significant to ensure safe drinking water standards and supports environmental water quality monitoring. The second technique that is used is filtration. Filtration removes suspended particles from water samples before analysis. Filtration process is from water that passes through filter paper that placed in a funnel. Secondly, the suspended solid particles are retained on the filter paper. And lastly, the filtered water, which is filtered, is collected for further analysis. Filtration is important to improve the accuracy of subsequent analysis by eliminating physical interference from particulate matter. Why filtration matters? Well, filtration removes turbidity and suspended solids that may interfere with titration, spectrophotometry, and other analytical techniques. Other than that, it also ensures cleaner, more reliable water samples for precise chemical measurement and accurate results.
Reagents that used to analyze water monitoring is ethylene diamine tetraacetic acid. solution EDTA. This is chelating agents that binds calcium and magnesium ions to produce measurable reactions in water hardness titration. Second reagents is buffer solution. Buffer solution helps maintain pH stability and ensure the endpoint detection is accurate. Other than that, buffer solution also improve analytical accuracy in water analysis. Third, indicator known as areochrome-black signals titration endpoint. This reagent ensures proper reagent selection to get more reliable and consistent results. Our group example analysis is water analysis hardness determination. The objective is to determine calcium and magnesium ion concentration in a water sample using EDTA titration method to assess water hardness levels accurately. So how do we prepare for this water hardness analysis? First, we prepare standard EDTA solution. Second, we measure water sample volume. Third, we add buffer and indicator. Fourth, we perform titration until endpoint. And lastly, record endpoint volume hardness that calculated from EDTA volume used.
To illustrate the result, let us look at this example on water hardness quality analysis that we conducted on sample A using the EDTA titration method. Total hardness obtained is 120 mg per liter as calcium carbonate equivalent. If we break this down further, calcium hardness is accounted at 85 mg per liter while magnesium hardness accounted at 35 mg per liter. So what does this actually mean in real life? Sample A is classified as moderately hard water. This means that it is suitable for most domestic uses such as cooking or showering. However, it might cause minor scale buildup in pipelines or appliances over time. Even drinking this water has its own acceptable limit. Nevertheless, the EDTA titration method successfully determined the water hardness level, confirming water sample A is safe for general house consumption.
Analytical chemistry in water monitoring plays an important part in monitoring and providing accurate data that supports public health, environmental protection, and industrial operations. So, what is benefits of analytical chemistry in water monitoring? One of it is to get accurate assessment of water quality and to detect early detection of contamination in water. Not only that, it's also to support environmental regulation and protects public health. Industries that involve in water monitoring are water treatment plants, environmental laboratories, and food and beverage industries.
Finally, this brings us to our conclusion. Apparatus gives us the accurate measurements we need for a reliable data. Techniques such as titration and filtration were used here to ensure our analysis is systematic and reproducible. Reagent drive the essential chemical reaction that allows us to detect and quantify these otherwise invincible minerals and contaminants. Ultimately, it is the combination of these elements that produces dependable analytical results, giving us the power to safeguard both environmental and public health. Thank you for your time, and bye-bye!